Hello students, I'm going to work out the problems that are on the multiplication division strategy worksheet. That way you can see the processes that are employed. For the first one, partitioning strategy, we pretty much use the split strategy or similar to the split strategy that we used for addition, but we apply multiplication. It really is the distributed property at work because we would expand 347 into what we call expanded form. Expanded form is just writing each place value. So we would rewrite 347 as 300 plus 40 plus 7. That is multiplied by 7, and now you would just apply the distributed property, multiplying 300 by 7, 40 by 7, 7 by 7. So we'll go ahead and do that. And we tend to write this vertically just to get students in the habit of stacking because that's what we do with the standard algorithm. So even in our presentation, we're starting to scaffold. So we get 2,100 when we multiply 300 times 7. We get 280 when we multiply 40 times 7. And we get 49 when we multiply 7 by 7. Now we'll add vertically. And in doing so, we will get 2,429 as our product. For number 2, we're going to use compensation. With compensation, you take the number that is not a benchmark number or a base 10 value and you round it to the nearest. So we're going to round 38 to 40. We're multiplying that by 80. And in doing so, we get 3,200. But we went up too many 80 times. Because you have to remember that the quantity that you go up by, you're then multiplying it by the other factor. So we have to take away 2 times 80, which is 160. And then we would subtract, and we would get 3,040. Now we're going to use an open array to multiply 23 and 45. The open array is the distributed property at work too. In all honesty, it's the FOIL property, but the students have no idea that they're doing that yet. But once you do get to teaching students FOIL in 9th grade, you can say, hey, we've done this before and we've looked at an open array. How so? Because you break up each number into 2, into its tens value and into its ones value, and you put them in each place. So let's go ahead and break up 23 to 20 and 3. And we'll place those vertically, and then the 45, 40, and 5. Now remember, you could change and put 45 here and 23 here. Order doesn't matter with multiplication. So we then multiply each of our sets of factors, and we put the products in each of these squares. So we get 800, 100 when we do 20 times 5. 3 times 40 will give us 120. 3 times 5 will give us 15. And then we take each of those. We have 800, 100, 120, and 15. And we're going to add vertically, and that will give us 5, 3, and 10. 1,035 is our answer. Question 4, can you think of a way to teach students how to use the standard algorithm to multiply 271 times 8 without caring as you multiply? So how can we do this? By partitioning. So you could have the students go ahead and set it up vertically so that they get accustomed to this. But you just say, hey, we're really multiplying 8 times 200, 8 times 70, and 8 times 1. 8 times 200 would be 1,600. 8 times 70 would, 8 times 70 would be 560. And then 8 times 1 would be 8. Then we just add vertically. And we get 2,168 as our answer there. And again, the students didn't have to carry, so this is a nice scaffold or cross-check to the standard algorithm. Now, when we are scaffolding to the standard algorithm, the very first thing that you would model to students is the physical idea of sharing an amount among a certain amount of groups using physical manipulatives, but also showing it with the explicit trade model. And this is the precursor to the standard algorithm. So over here, we're going to model the explicit trades and bring down. And here will be our physical trades. So we set up first using our notation the 614 divided by 4 using our division symbols. And then over here we express the 614 with 6 100 squares, 1 10 squares, and 4 little guys. We're putting those into 4 groups, so we're going to create 4 circles. And what we're going to do next, and I realize that I'm a little off of the screen here with my circles, so I'm going to just adjust my camera a bit. Sorry about that. Okay. So what we're going to do next is we're going to ask ourselves, how many of these hundreds can we place evenly into these 4 groups? Well, we can place 1 of each into these 4 groups without splitting the remaining 2 up. So we put 1 into each of them. We cross those out. We record it over here in the standard notation. 1 times 4 is 4. 6 minus 4 is 2, which means we have 2 hundreds left, and we see that over here. We don't want to break those up into halves, which we could do, but we're talking about how many holes we can put in those. Well, we can't put any holes without breaking them up, so we have to explicitly trade those 2 hundreds for 10s. So I'm going to cross these out, but put a little arrow indicating that I'm now trading these for 2 sets of 10 10s. 2 sets. So that's going to be 20 10s total. And then I record that trade here. I'm trading the 200s for 20 10s. 1 plus 20 means that I should see that I have now 21, and I do. These 20 plus that one, 21 10s. How many of those 21s 10s can I put evenly into each of these 4 groups? I could put 5. So I'm going to record the 5 into each of these little groups. I record the 5 up here. 5 times 4 is 20. I subtract, and after I've crossed out my 5s, I should see that I have just 1 10 left. And I do. That 1 10, I cannot, without breaking it up, put it evenly into those 4 groups. So I need to explicitly trade it. So I'm going to come up here and I'm going to trade it for 1 group of 10 singles. I'm going to cross it out and put a little arrow indicating that I'm trading this for 10 little singles. Now I have 4 plus 10, I have 14 ones. Now I could have made this a little neater and spaced it out, and I really should if I'm teaching this and modeling it to students, so I apologize that I did not. I'm in a really weird configuration. I have my phone stacked up by, gosh, 15 textbooks here because I can't find my tripod. But we're modeling flexibility and embracing it this semester, so I'm doing the best I can. At any rate, hopefully if I were modeling this to youngsters, I would have it lined up much more neatly. But you see I'm adding the 4 and the 10 ones to get 14. I see that I physically have 14 ones left. I can place a total of 3 of those into each of these 4 groups. And so that is what I'm going to do. So I placed 3 of those. I'm going to multiply the 3 times the 4, which would give me 12. I'm crossing out 12 of these, showing that I will have a remainder of 2 left. And we get that when we do the 14 minus 12. We should see modeled physically in each group 153 with a remainder of 2 left outside of the group. And we do see that. Let's come down to the products. We are asked to estimate the following product and quotient respectively using either rounding or compatible numbers. So you get to decide what you would like to do. I'm thinking what I would like to do here is round this to 600 and then round this guy to 20. And then that would give me about 1,200. So I chose rounding here. Okay, 435 divided by 95. I'm going to choose compatible numbers. What am I going to choose as my compatible number? I'm going to move this guy up to 450 because 45 is a number that 9 divides into. So I'm just going to change that one. So 450 divided by 9 would give me roughly 50. Really easy way to do some quick mental math. You want to be flexible. A student might choose rounding instead, but you want them to be using number sense and thinking of numbers that multiply and divide easily in order to facilitate and help them be more efficient with their mental math.